Hello everyone, it's Evan. Today I'm talking about my functional Lego punch card reader machine. For those who don't know, a computer data punch card refers to a technology from the 1950s, 60s, 70s. Back then you would have your computer data on a bunch of pieces of paper. Each piece of paper, sort of like a cardstock paper, would be 2 or 3 inches tall by about 6 or 7 inches long, and you'd have hundreds of little holes in them. Where there's a hole is a 1, where there's not a hole is a 0, and you would use a machine called a key punch to make the holes. Every piece of software you wrote, every program, your code would be hundreds of those cards in a big stack. And then you'd feed those cards into a machine called a punch card reader, which tells an IBM mainframe or a similar computer the size of, a box truck what to do. Generally, that kind of data will be, say, payroll, inventory, launching a nuclear battleship, that kind of thing. I don't know if a nuclear battleship is actually a thing, but you get the idea. These kind of punch card software was used for giant commercial and government military applications. Nothing you would ever use for a personal computer. Personal computers came out in the 1970s. Anyway, I don't happen to have a 1960s or 70s IBM mainframe bigger than my house, but I have Legos. So I decided to build a fun demo. Instead of a big old IBM mainframe, I'm using an Apple IIe Platinum, which is a common home computer and common educational computer from the middle of the 1980s. And that is this computer over here. It says Lego Buggy Machine, and it shows my website, brickhacks.com. My software is on 5¼ inch floppy disk inside those disk drives. And I'm using 3 Lego Interface A devices. Quickly, I have other videos all about Lego Interface A, but generally it is an 8-bit device connected by a parallel port to let your common 1980s home computers talk to your Lego models. I programmed this in a language called BASIC, which is a beginner's beginner's all-purpose symbolic construction code. It's a beginner-friendly general-purpose program language. It's interpreted, not compiled, general-purpose, and beginner-friendly. So it's sort of similar to, sort of metaphorical to Python today. Anyway, for this demo, I made 4 kinds of punch cards to control my little buggy robot. They're labeled front, back, left, and right, FBL and R. The ones that make the robot go forward have no holes on them. They're unpunched, if you will. The ones that make the robot go backward have 2 sets of holes in them. The ones that make the backward robot go left have a hole on the left. And then to make the robot go to the right, have a hole on the right. There are touch sensors inside the machine. And so where a touch sensor is not pressed, it means there's a hole. Where a touch sensor is pressed, means there's not a hole. And then my software knows what to do with that data. So I'm going to put 4 cards into the machine on the right side. One by one, the machine will read the cards in, pause, read the data, send the cards on the way, collect them in the hopper. So now I'm going to have a demonstration. I'll insert 4 cards. The forward, the reverse, the left, the right. And we'll zoom in here on the machine. And I'll hit the start button. Reading the data. And collects it. Reads the data on the second card. Collects that. Reads the third card. Collects that one. And reads the last card. Collects that one too. And the robot moves accordingly. So that's my machine. Again, it is a functional punch card reader. And basically, when I display this at LEGO conventions or whatnot, I let visitors choose any 4 cards they want, hand them to me, and I put them in a machine, execute the code. And I explain to visitors that while I wrote the code to read the cards, they effectively wrote the code to move the robot. It's a great educational tool. I find people do understand it pretty well. A lot of times if I ask people what punch cards are, they assume I mean like a time card, something you'd use at work. But I explain to them, and they usually surprise me. They usually get it pretty well. So I could, plenty of ways I could expand this. I could make more than 4 cards. I could make it faster or slower or more precise or less precise. Well, not really precise. It's digital after all. And I don't know if you noticed in the demo, but I should have mentioned this. The 4 lights on top here. The one on the right is red for power. On the left is red for power. Second from the left is green for feed. Second from the right is yellow for read. And then on the right is blue for execute. So that's all for now. Please post questions in the comments. Thank you.